So we ran out of time to finish our math, but I'm going to go and finish it and then do the homework. So I will try not to be so long-winded. All right, so we are going to add 2 7/8 to 1 1/4. And I'm just picking different colors here for no reason other than to make my picture, my math homework colorful. All right, so I'm going to do 2 7/8 plus 1 1/4. I gotta get a sweater. It's so cold. All right, much better. Good thing I live in California. All right, so we have 2 7/8 plus 1 1/4. So we're doing models so we can see what we're doing with our math, right? That's the only reason we're doing this. We could do this without any of this part, right? This is just so we can see it. All right, so 2 7/8 and 1 1/4. They cut this one up into 8 pieces. Right, this one is not cut up into 8 pieces, or is also cut up into 8 pieces, but I started with fourths, right? So I would have 1/4. I could make this into fourths. They already broke it up into 8s. I can't add 2 fractions with unlike denominators. I can't add 8 and 4. So I need to change my denominator here to an 8, right? I'm going to change 1/4 into an 8. I'm going to cut it up into 8 pieces now. I changed my bottom to 8 pieces, so I have to change the top as well. I can't just say it's equal if I did something. I multiplied here times 2, so I'm going to multiply my numerator as well times 2. 1 times 2 is 2. So now I will have 2 8s. So I'm going to color. So I'm going to color 2 7/8. I'm going to color 1, 2, 3, 4, 5, 6, 7 out of 8. You can see I just need one more 8th here to make my circle complete till I would have one. So then I'd have 3 whole circles, right? Plus that one, 4 whole circles. So here I need to color 1/4. So I colored 1/4, but when they broke it up into 8s, you can see I colored 2 8s. 1/4 is the same as 2 8s. Oh, and I can't forget to color my 1. All right, so now I'm going to add these together. So hopefully you see what I'm going to do is take one of these 8s and put it up here. That'll make that complete, and then I'll still have 1/8 left down below over here. So I'm going to say 1, 2, 1, 2, 3, and 7, 8, 9, 8s. Right? There's a lot of different ways. I can't leave it like that. It's an improper fraction. There's a big number on the top of the fraction. That does not work in fractions, right? It works. I can leave it. I could, have it like that, but it's just called an improper fraction. 9 8s. There's a bunch of different ways I can change it. Remember, a fraction is just a division problem. It means 9 divided by 8, right? 9 8s is the same as 9 divided by 8. I'm going to do my little work here. How many 8s are there in 9? There's 1 8 in 9, right? 1 times 8 is 8. I subtract, I'd have 1 left over. When I have a remainder of 1, but I'm working with fractions, so I'm going to take my remainder. It's going to turn into my new numerator. My number I was dividing by is my denominator, so I have 1 and 1/8. So 3 and 9 8s is the same as 3 plus 1 and 1/8, which is the same as 4 and 1/8. This is my final answer, 4 and 1/8. If you need to pause it, pause it. I'm going to keep on going. I'm going to get a new color. I should pause while I'm doing this because I'm so slow. All right, here we go. 2 1/2 plus 2 1/4. Right, so we can see here I did 2 1/2 and 2 1/4. We're going to color them 2 1/2 of this circle. They already cut it up into fourths for me though, right? So I'm just doing this again so we can see what I did. I turned this half into fourths. To turn that 2 into a 4, I multiplied it times 2. whatever I do to the bottom, I have to do to the top. 1 times 2 is 2. So 1/2 is the same as 2 out of 4. My bottom was 2 1/4, so I'm going to color 1, 2, and 1/4. Alright, so hopefully now you guys see I have 1, 2, 3, 4. And I'm counting fourths over here, right? I have 1, 2, 3 fourths. Next problem. I did pink and then darker pink, so I'm going to do green and darker green. Alright, so 2 3/4 to make my little patterns and colors. So 2 3/4 plus 2 1/8. Right, I'm just moving this over here. I cut it up into 8ths because I needed to, right? I'm going to need to cut this up into 8ths. I can't add 4ths and 8ths, but hopefully you can see it is 4ths there, right? And then I just cut up each 4th into an extra piece. So I have 2 pieces. All right, so I'm going to color 2 and 3/4. So I'm going to color 1, 2, 3/4. And here I'm going to color 1, 2, and 1/8. Which one should I color? How about you? Alright, so now I'm going to add them together, right? I changed this 4th. It had 4/4, and I changed them into, and they had 8ths. Sorry, I changed it into 4ths, but they had it measured in 8ths. So I just want to show you 3/4 is the same as this many 8ths, right? I can count them. 1, 2, 3, 4, 5, 6 8ths, right? There's 7 8ths. 8 8ths would be the whole circle. So I just want to show you 3/4 is the same as 6 8ths, and I can do this with math as well. To turn my 4 into an 8, I multiplied it times 2. If I multiply the bottom times 2, I have to multiply the top times 2. 3 times 2 is 6 8ths. So, right, we have 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6 8ths up here. Right, I'm going to add one more 8th, though I should have 7 8ths. So now I'm going to have my 2 plus my 2, and my 6 plus my 1. Right, this is almost 5. So super close to 5. All right, on to the back. Eduardo worked 1.5 hours on Monday, 1.5 hours on Tuesday, and 2.5 hours on Wednesday. How many hours did he? All right, so we are going to add up his hours. They want us to do fraction circles, right, so we can see this. We have halves, so that will be easy. We don't have to change any denominators here. So I have 1.5 plus, I'm going to do it this way, 1.5 plus 2.5. Let's color. You didn't know you'd be coloring in 5th grade, huh? 1.5 plus 1.5 plus 2.5. So hopefully you guys can see, if I take this 2 halves and put them together, I will have one more whole one. So I'm going to count. I have 1, 2, 3, 4, 5, and 1/2. So I'm going to say 5 and 1/2 hours. Don't forget what we're counting, right? The whole thing we're counting. It says use fraction circles to solve. So make sure you show your work, right, when you're doing these problems. You don't just write your answer. I could have added these, right? I could have said, let's do it up here. Will you write with me? I could have said 1 and 1/2. We're going to do it just like we would do it with just numbers, no pictures for 5th graders. We don't need pictures anymore. No, just kidding. It's a good idea. It's good because you get to see it visually. It's awesome. All right, so now I'm going to count. I have 1 plus 1 plus 2 is 4. I'm going to count my halves, right? I have my denominator, 2, 2, 2, 2. It stays a 2. I don't change it. 2, 2, 2, 2. I add the numerators. I'm going to have 1, 2, 3. So I have 4 and 3/2, right? But you know, your brain, if you see it like this, the bigger number on the top of a fraction, your brain should be going, little alarms, right? No, there's something's, right? It's not anything wrong with it. I just don't leave it like that. So 3/2, right? 3/2 is just a division problem. 3 over 2 is the same as 3 divided by 2. Right? And there's a bunch of different ways I could divide 3 up by 2, but this is how I've been choosing to do it. So I'm going to take 3 and divide it up by 2. This is really just the only way I know how to do it. I'm going to have to find out some other ways to do division, but this is how I learned when I was a kid, and I think most of my friends do it this way too. So this is how I show my work and how I work out a division problem. Can 2 go into 3? Yes. How many times? 1 time. 1 times 2 is 2. I subtract, I have 1 left over. Now, right, if I was doing decimal places, I'd put my decimal place, add my zeros, keep on going here, right? I'd have 1.5, but we're not doing that. Or if I was just doing math like before, I'd put 1 remainder of 1, right? I'd write a little r and put 1 remainder of 1. But I'm doing fractions. So in fractions, what I do, I take my remainder and it becomes my numerator. The number I'm dividing up, I'm still dividing up by that same number. So now I have 1 and 1/2. So 3/2, 3 divided by 2 is the same as 1 and 1/2. So right, I was taking my 3/2, this really is equal to 4 plus 3/2. So it's going to be equal to 4 plus 3/2 is the same as 1 plus 1/2. So now I'm going to say 4 plus 1 plus 1/2 is going to be 5 and 1/2. I have the same answer, just double checking. Sorry, I'm moving so fast. Alright, so next problem. Marissa walked 1 1/4 miles to the store. Right, I could say 1 1/4, 1 1/4. When I count fourths, I have a little name I can call them quarters as well. Right, I could have I'll keep going. Marissa walked 1 1/4 miles to the store. She walked the same distance back home. How far did Marissa walk all together? Right, so I'm just taking 1 1/4. I could multiply it times 2, but we have not got there yet with fractions. So, plus, we'll do it the old-fashioned way, 1 1/4. So I'm going to do draw my picture. Let's see, I'll separate it over here. Right, if I was doing this really for my teacher and stuff, I would do stuff like this. I'd let my teacher know, oh, this one's a number. Right, that's the symbol, that hashtag is a symbol for number as well. Number 8, and I'll put number 9 over here. So I show my work, 1 1/4. So I'm going to do 1 1/4 plus 1 1/4. I will color them in. I'm going to use my same green since I have it out. 1 1/4 plus 1 1/4. Right, hopefully you guys can see this is 2 2/4. 2 2/4. But if I took this one and moved it up here, can you see if I moved it up here, I'd have 1/2. 2/4 is also equal to 1/2. Right, the way I do this, I take 2/4. I see that the greatest common factor that these numbers have, right? This could be 2 times 1, and this could be 2 times 2. So the greatest common factor they have in common is 2. So I'm going to divide the top by 2 and divide the bottom by 2. I can't add or subtract. I multiply or divide, but if I do it to the top and the bottom, I will still have a nice even fraction there. 2 divided by 2 is 1. 4 divided by 2 is 2. So now, back over to my problem, right, I needed to fix my 2/4 into its simplest terms. So now 2 2/4 is the same as 2 1/2. And what were we counting? Millas. How many miles she walked to the store? Alright, I'm practicing my Spanish so I can be a Spanish teacher. Write and solve a real-world problem that could be represented by the fraction circles shown. Right, so I can just write anything. I can write about, how about milk? Because I sell milk by the gallon, and I sell it by the quarts also. So I'm going to say, and we'll pick a name. I should pick one of your guys' name, but I'm not going to. I'm going to say Vanessa. I think I'll spell Vanessa with 2 S's. Vanessa bought, well, you can't buy them in like that. How much? We'll say she drank 1 3/4 gallons, right? It's more than 1 gallon, so I put an S at the end. If it was 3/4, I'd just say gallon without the S. But I have 1 3/4 gallons of milk. We'll say the first week of March. I'm going to put a capital M because it's the name of my month. Vanessa drank, I should put a K at the end of drank so I spell it correctly. Vanessa drank 1 3/4 gallons of milk the first week of March. Her brother drank, I was going to do a different problem, but I'm changing it up. So her brother drank 1 2/4 gallons of milk. These kids really like their milk. How much milk did they drink? I'm just going to add it together. 1 2/4 plus 1 3/4. They didn't ask me to, oh, it does say solve, right? It said write and solve. I have to solve it as well. So they already drew the pictures for me, so I don't have to do that. So I could use their pictures, and I could just, how about I'll write it right up here next to them. 1 3/4 plus 1 2/4 equals 1 2 and 1 2 3 4 5 fourths. Hopefully you can see if I took one of these fourths and put it over here, I'd have 1 2 3 whole circles plus 1 little fourth left, right? Which is my final answer. 3 and 1/4. So, right, there's lots of different ways I could have got there. Since they gave me the picture, that's what I was looking at. 3 and 1/4. I'm going to take 1/4, stick it over here, and then I'll have 1 2 3 plus 1/4 left. 3 and 1/4. Just for practice, we can do it this way too. My 5/4 to change it into a number, right? So I'd have 2 and 5/4. I'm going to change my 5/4 by taking 5 divided by 4. 4 goes into 5 one time. 1 times 4 is 4. Subtract 1. I take my remainder, it becomes my new numerator, and I was dividing by 4, so I'm still going to divide by 4s. 1 and 1/4. So 2 and 5/4 is the same as 2 plus 1 and 1/4, which is 3 and 1/4. I solved it. Ooh, gallons of milk. So right, I wrote my problem, I solved it, I even did some work up here. My teacher wants to see my work. Done. A+. How can I use fraction circles to find the sum of mixed numbers? So, we draw our fraction circles, we color in the fraction of the part that we used, we shade them in, and then we write in its simplest form, right? We add the shaded whole numbers, we add the fraction whole numbers shaded, and then we write it in its simplest form. So I use fraction circles, right? I'm just going to use the question to answer it. They said, how can I use fractions circles? I don't think they meant to say fractions circles. I think they meant to say fraction circles to find the sum of mixed numbers. I use fraction, I'm going to do fraction circles. I'm not putting that S on it. To find the sum of mixed numbers. Right, I just use their question to write my answer. It takes a long time, but then I know I have a great answer. I use fraction circles, and I even fixed their S over there. I use fraction circles to find the sum of mixed numbers by shading the circles, I'm going to use a good word here, to represent, I'm copying it out of the book of our math book. They use the word represent. I changed their sentence a lot, otherwise it's so longer. Sorry, it was a little longer. Circles to represent the mixed numbers I count the shaded parts together and write in simplest terms. I'm realizing your book did have a shorter answer. It just was kind of convoluted. All right, I'm ready for the homework. If you didn't finish that, pause it. All right, here's our homework. So here's our example, right? It always gives us an example. We're on lesson 10, page 675. I'm going to do 2 videos, so it's